In today's session, we're going to be building on what we covered in the previous lesson, which was encryption, and we're going to be looking at how encryption is implemented on the web. By the end of this particular lesson, you'll have a greater awareness of secure sockets layer, SSL, and transport layer security protocols, which are quite common on the web. We're also going to be having a quick look at public key infrastructure, which powers all of this, before we move on to digital certificates and digital signatures in a future lesson. So as usual, let's begin with some key terms. Do pause the video and take these down. Let's start with secure sockets layer, SSL. This is a security protocol which is used when sending data over the internet. Transport layer security, TLS, is a more up-to-date version of SSL, and chances are that if you're watching this on YouTube, then you're probably using some form of TLS. Handshake is the process of initiating communication between two devices, and this begins when one device requests another device to exchange data. Session caching is a function in TLS that allows a previous computer session to be remembered, therefore preventing the need to establish a new link each time a new session is attempted. And we'll look at this in a bit more detail later. Certificate authority, CA, is normally a commercial organization, a company that is used to generate a digital certificate requested by a website owner or individuals. So this is the authority that will verify that a certificate is genuine. And finally, PKI, public key infrastructure, is a set of protocols, standards, and services that allow users to authenticate each other online. This is done through the use of digital certificates, which are normally issued by the Certificate Authority or CA. Let's begin by looking at the protocols for security, and there are two main protocols used to ensure security when using the internet, and these are Secure Sockets Layer, SSL, and Transport Layer Security, TLS. TLS is more modern, it's based on SSL, and the primary use of both SSL and TLS is normally in the client-server type of application. So whenever you're requesting information from a web server, you are probably using SSL or TLS. They both use standard cryptographic protocols to ensure there is a secure and authenticated communication between client and server. The most common one currently is RSA. However, there are a number of encryption protocols that are being used as part of SSL and TLS. Normally, the server is authenticated with the client remaining unauthenticated in most cases, because you need to trust that you're getting information from the right place. And these certificates tend to be quite expensive to buy in the first place. So a company or a bank or a school, for example, will probably buy a certificate from one of these certificate authorities to verify that they are who they say they are. And once a secure link between the server and client is established, SSL or TLS protocols ensure no third party can eavesdrop. So let's look at SSL in a bit more depth. When a user logs onto a website, SSL encrypts the data, so only the client's computer and the web server are able to make any kind of sense of what is being transmitted. It also allows two other functions, which are data compression, reducing the amount of data being transmitted, and data integrity checks to make sure that nothing goes wrong during the transmission. A user will know if SSL is being applied when they see the HTTPS protocol or a small green closed padlock in the address bar. The browser address display is different when the HTTP, which is the normal version, or the HTTPS, which is the secure sockets layer version of the protocol, is being used. And you can see an example of that on screen. Chances are that when you look at YouTube, you either will see HTTPS in the browser address bar or a small padlock. The SSL process works along the following lines. Transport Control Protocol, TCP, is used to establish a connection between the client and the server. A handshake takes place, thus enabling communication to begin between client and server. One part of the SSL protocol is to agree which encryption algorithms are to be used, for example RSA. This is essential to ensure a secure encrypted communication takes place between the two devices. And to be able to create an SSL connection, a web server requires an SSL digital certificate. The website owner needs to obtain this certificate from a certificate authority to allow SSL protocols to be used. Now, most browsers will have the addresses of these certificate authorities, verified certificate authorities, as part of their makeup. You might think that, well, can somebody set up a fake certificate authority so you can create fake SSL certificates just to trick people? It is possible. However, the chances of you actually injecting that certificate authority and making it verified are very rare. You might need an immense amount of access to domain name servers and perhaps actual core browser technology for that to happen. It's probably much simpler for you to just install a malware on a user's computer and redirect aka farming type approach, rather than just changing and accessing certificate authorities. Now you can view the certificates that are issued by a web server very easily. All you need to do is click the green padlock or the padlock that you might have on your browser window and then check the certificate details. On screen is an example of a certificate from bbc.com. Obviously it says this one is issued to BBC. It's issued by a company or a CA named Avast Trusted Certificate Authority. Avast is an organization which is also famous for virus checking and all sorts. So the validity period is there, March 22 to April 23, so it's a valid certificate and it's using an SSH 256 algorithm, and the fingerprints are on screen. Now, if you click on the details tab, you'll see a lot more details about the public key. You can view the public key. It's a 2048-bit public key, which is very hard to decipher by modern computing standards. Now, both SSL and TLS generally have the same uses. We're going to be looking at TLS in a bit more detail, but TLS is just an enhanced version of SSL. So they're both used for the same thing. If in an exam you're asked, okay, what are the uses of SSL or TLS, chances are you can get away with the same answers. For example, online banking and all online financial transactions are going to be using some form of encryption. Online shopping, commerce, sending software to a restricted list of users, sending and receiving emails, using cloud storage facilities, intranets and extranets, as well as the internet, all use encryption. Using VPNs or using voice over internet protocols for video and for audio chatting over the internet also uses SSL and TLS. Using instant messaging like Line, WhatsApp, you name it, uses encryption as well. And of course, social networking sites use encryption too. So what if you had a website which only sends you HTML information? There is no login process, there's no secure information that needs to be exchanged. Nowadays, even those websites use SSL and TLS because you need to verify that the website you're getting just HTML data from is actually who it says it is. For example, somebody could just set up a fake server and send you HTML information and package some malware in that HTML information. So that verification is a must. And the reason we use encryption here is that chances are that hackers aren't going to spend thousands of dollars buying these expensive certificates because they're in the business of making money, not spending money. And to get one of these certificates, you need proof of address and IDs and all sorts of things, which a hacker is unlikely to give. Okay, let's look at TLS in a bit more detail. TLS, or Transport Layer Security, is a modern, more secure version of SSL. It provides encryption, authentication, and data integrity in a more effective way. It ensures the security and privacy of data between devices and users when communicating over a network. When a website and a client communicate over the internet, TLS prevents third-party eavesdropping, so far just like SSL. But what's the difference between TLS and SSL? Where TLS is formed of two main layers. The first one is the record protocol, which can be used with or without encryption. It contains the data being transmitted over the network or the internet. And then you've got the handshake protocol, which permits the web server and the client to authenticate each other and to make use of encryption algorithms. So a secure session can be established between both of them. Now think about it this way. When we have an SSL protocol, both of these layers are together, so everything is encrypted. And if you want to update to a new encryption method, you will need to update the entire SSL protocol. In TLS, what we can do is we can extend the TLS protocol by adding new authentication methods just on the handshake layer. So we keep the record layer separate. There are other advantages of why TLS is better. TLS can make use of something called session caching, which improves the overall performance of the communication when compared to SSL. And we're going to be looking at that in a bit more detail. So in an exam, when you're asked why is TLS better than SSL, you've got to be able to articulate these 3 points. That TLS separates the handshaking process from the record layer, where all the data is normally held. TLS can make use of session caching to improve performance, and it's possible to extend TLS by adding new authentication methods, unlike SSL. Once you make SSL, you cannot upgrade that particular protocol. You've got to come up with a new version of SSL, whereas the same TLS can just be improved by updating the handshake layer. Now, why do we still use SSL? Well, that's because most web browsers support SSL. However, the recent web browsers support both SSL and TLS, and because of the older legacy browsers supporting SSL, we're still keeping it on board. However, over time, SSL will be superseded by TLS protocol if people want to use the internet, because that's the direction web development is going into now. So let's study session caching in a bit more depth now. When you open a TLS session, it requires considerable computer time, and that's due to the complex cryptographic processes taking place. So those 2048-bit keys need to be deciphered. Now, imagine what happens that every single time you're connecting to a web server, you've got to exchange the keys and you've got to decipher this 2048-bit key. It will slow everything down on your computer. So the use of session caching can avoid the need to utilize as much computer time for each connection. So TLS can either establish a new connection every time or attempt to resume an existing session because it's already worked out the key. And using the latter can considerably boost the system's performance, because you're not just sitting there calculating keys and making sure that the keys match. You say, well, okay, we've exchanged the keys, that's what it is, let's resume this existing session, and that speeds up things. And that's all session caching basically is, to cache the session and resume it rather than recalculate a new cryptographic key. Now, to summarize what we covered so far, both SSL and TLS are used for the encryption of data. They allow the identification of client and server to ensure each one knows who they are communicating with, so that authentication is part of the process. Of course, both of these do it in slightly different ways, and you need to ensure that you understand that TLS breaks things down into two layers, whereas SSL keeps everything together. Now, one of the most common questions that you'll encounter in the exam is, how does SSL or TLS work? And you will need to list down the various different stages of the process. This is a very simple question to answer, because chances are that you've actually done this via your browser countless times, but you never think about that particular process. So we're going to break this down into a number of stages. Again, this could be a 4 to 6 marker, and as long as you remember these stages, you're going to get full marks. So the first stage is that the client types in the URL into the address bar, and at this particular point in time, several steps will occur before any data is sent. This is known as the handshaking stage. The client's browser requests secure pages from the web server. The web server sends back their SSL or TLS digital certificate, which also contains the public key. And this certificate is digitally signed by a third party called the certificate authority. So once the client's browser receives the digital certificate, it checks the digital signature of the CA. Is it the same as one of those in the browser's trusted store? Because if it's not, then the certificate authority itself is invalid and you shouldn't be doing anything else. If it matches, then it checks the next part. Are the start and end dates shown on the certificate valid? It also checks if the domain listed in the certificate is an exact match with the domain requested by the client in the first place. Once these checks are done, the browser then trusts the digital certificate. The public key, which is part of the digital certificate, is used by the browser to generate a temporary session key. This session key is then sent back to the web server, which is like your public-private key approach. The web server uses its private key to decrypt the session key and then sends back an acknowledgement that is encrypted using the same session key. Now the browser and the web server are in sync, and they can now start encrypting all the data over the connection using the session key. A secure communication is now taking place. Now this process works for both SSL and TLS, and it uses something called the public key infrastructure to make all of this happen. Now before we get into that, please make sure you understand the different stages a browser goes through before secure communication can begin between a browser and the web server. Remember, all of these are part of the handshaking stage. The data exchange happens in stage 7 only. Right, let's just have a quick look at public key infrastructure, the final part of this particular session. The public key infrastructure is a set of protocols, standards, and services that allow clients and servers to authenticate each other using digital certificates, which are normally issued by a certificate authority. Digital signatures also follow the same protocol. Now, PKI requires the provider to use an encryption algorithm to generate public and private key. The image on screen simplifies this process. The web server normally will get a certificate or a digital signature from a certificate authority. The certificate authority itself is registered by an organization called registration authority, and the server will probably check this registration authority to identify whether the certificate authority is genuine in itself, because we don't want like a group of hackers to set up a certification authority and then start issuing digital certificates to everyone. So this registration authority will check that the certificate authority is genuine. Once it's verified, then the web server will purchase the digital certificate from the certificate authority. This digital certificate or the digital signature will then be sent to the user whenever they want to get information from the server. The user will then verify the digital signature or the digital certificate by connecting to the certificate authority, and that's the process, that's the loop that happens in verification of digital certificates or digital signatures using public key infrastructure. At any stage, if the certificate or digital signature is found to be not genuine, communication stops. Okay, that's the end of today's session. Hopefully you've understood how SSL and TLS work. You should also have an idea of the common uses of SSL and TLS. You should understand the process of session caching and what is meant by public key infrastructure. You should also be able to explain how SSL and TLS protocols operate using a browser. The last one is very important. As usual, if you do have any questions, please do get back to me. Otherwise, I'll see you in the next one.